We're continuing to look at CSEC Mathematics, May 2024 paper, and we're at question 10. Now, part A says the determinant of the matrix 6, 2v, negative 5, negative v is 24. Calculate the value of v. What did you get for the answer? Can't remember, You're supposed to make a genuine effort at working out the question before you watch the solutions, right? That's part of your homework. Other parts include, if you're not a subscriber, make sure you subscribe to the channel and share the video with somebody else. And if you find that there's any value in these videos to you, then you can make a comment saying a thank you or so in the comment section. If there's anything that you want to question, you put the question there, right? Make sure you do those things. Now, the determinant is 24. You remember how to find the determinant of a matrix? If you have A, B, C, D as your matrix, the determinant equals, sometimes it's written like this too. Same thing as determinant is equal to AD minus BC, right? You have to remember that. So, in this case, all right, let me keep it. Not bother to erase it. In this case, what you would have, A times D minus B times C. Following the same pattern is 6 times negative V minus 2V times negative 5. And they say it is 24. Alright? So, this is negative 6V minus times minus is plus 2, 5, 10V equals 24. Alright? You see that? Negative 6V plus 10V is going to be 4V equals 24. And then dividing both sides by V, by 4, V is equal to 24 over 4, which is 6. So, in this case, V is 6. Alright? So that is your answer there, 6. After that, you can see the yellowish markings. The flatbed scanner that I use has some flaws. So it's been a long time that I have that scanner using. So maybe it's developing some fault and showing us it's doing its time, right? Maybe it's the aging of the scanner. But anyway, part B. The matrices L and M are defined as follows. So you have L equal 9, 5, 3, 2, and M is 2, negative 4. Evaluate each of the following. The product LM. We want the product LM. So you're going to be multiplying these two matrices. So it's 9, 5, 3, 2 times LM, which is 2, negative 4. What did you get for LM when you did it? If you didn't do it, write this down and stop the video or pause it and go work it out on paper, and then you come back to it. Alright? Alright, so what you have here, remember, what you have is row 1, row 2. You have column 1, column 2. Alright? This has only one column but two rows, row 1 and row 2. In the answer, you're going to get the answer. First column is going to be column 1 by, no, is row 1 times the column. Alright? So it's first by first plus second by second. So it's 9 times 2 plus 5 times negative 4. And that gives you the answer, row 1 and the column. Next will be row 2 and the column multiplied. So give you row 2 times the column. There's only one column here in the second matrix. First by first, so it's 3 times 2 plus second by second, so it's 2 by negative 4, alright? So it's 3 times 2 plus 2 times negative 4. So what you get then is 9 2s 18. It's going to be minus 5 4s 20. And then 3 2s 6 minus 2 4s 8. So the answer you get is, well, it's negative 2, negative 2. So that's the answer. The product LM is negative 2, negative 2. See that? Alright, what else do they say happen? Okay. So here, each of the following LM. So you have LM here. So the next thing we do, oh, there's a next part here. The inverse of L. You want the inverse of L. Okay, let's see. L is 9532. Let's write it over here. So L equal 9532. What did you get for the inverse when you tried it? Let us see. Now remember, there's a general way to find the inverse of a matrix. If you have, for example, A, B, C, D, right? The inverse would be 1 over the determinant times interchange A and D. So D would go up here, A would come down here. So you have D and A down here. Change the sign of B and C. Alright, so that's what you have there. So let's do it to this. The 9532, or you don't have to write it, the whole matrix again. You have a name for the matrix, it's L. L inverse is equal to 1 over the determinant, and you know the determinant would be 9 by 2 minus, put 3 by 5, but it's the same thing, 5 by 3 times interchange A and D, interchange 9 and 2. 9 will come down here, 2 go up here, alright? So it's 2 up here, and 9. Change the sign of the 5 and the 3, negative 5, 3. So let's work this out. This is 1 over 9 2s 18 minus 5 3 15. But 18 minus 15, we'll just work that out. 18 minus 15 is what? It's 3. So it's 1 over 3 times 2 negative 5 3 9. Alright? And we can just multiply by the 1/3. It is 2 over 3, negative 5 over 3. It is 3 over 3, which would be 1. That's 1. And then 1/3 by 9, which would be 9 over 3. 9 over 3 is the same as 3. Alright? So that is what we have as the inverse. Alright, let us make sure. Let us just do a little thing to test what we did. 9532 multiplied by its inverse. 2 third negative 5 third times 2 third negative 5 third 1 3. When you multiply a number by its inverse, when you multiply a matrix by its inverse, what are you supposed to get? You're supposed to get what? The unit matrix. Alright? Just like how when you multiply a number by its inverse, you get the unit number, which is 1. Alright, so let us multiply these and see what you get. You have to remember how to multiply matrices. So row 1 times column 1 is going to be first by first, 9 times 2 third, plus second by second, 5 times 1. That gives you row 1, column 1 in the answer, right? Then row 1 by column 2. That's 9 by negative 5 third plus, that's the first by first plus second by second plus 5 by 3. Then row 1 by column 1 is 3 times 2 third plus 2 times 1. So you have first by first plus second by second, right? And that gives you row 2. Remember, this is row 1, column 2. You get it from row 1 by column 2, right? This is row 2, column 1. It comes from row 2 by column 1. And then this here now is going to be in row 2, column 2. It get it from multiplying row 2 by column 2. So it's first by first plus second by second, right? So it's 3 times negative 5 third plus 2 times 3. Alright, so let's simplify these things and see what happens. 3 into 3, 3 into 9, 3, 3, 2, 6. 6. So what you have is going to be 3 plus that. So what do you have again? 9532 times, and then you have, just checking to make sure everything is okay, 3. So this 9 by this plus 5 by this. Alright, so let's check everything. I'm seeing something, I'm not sure what's happening here. Let's make sure I didn't make a mistake. 9532. So you 1 over 9 by 2 minus 5 by 3. Interchange 219. Good. Change. Oh, I didn't change the sign of 3 now. Something was wrong. I had a feeling something was wrong somewhere. You change the sign of B and C. I didn't change the sign of 3 at all. My. I have to be so careful with these things. Yeah. So here, let's take another look at this. You interchange 9 and 2. So 2 come up here. 9 comes down here. Change the sign of 5 and 3. 1 over 9 by 2 minus 5 by 3. So it's 1 over 3 times 2, negative 5, negative 3, 9. And after that, you multiply out the 1/3 by what you have in the bracket. It's 2/3, negative 5/3, negative 1/3 by negative 3 by 1/3 gives you negative 1, negative 9 by 1/3, or you could say 1/3 by 9. So it's 1/3 by negative 3 gives you negative 1, 1/3 by 9 gives you 3. Alright, so that's what we have as the inverse. And if we multiply the matrix by its inverse, we're going to get 9 by 2/3 plus 5 by negative 1/3. Alright? And then after that, we have So it's 9 by 2/3 times 5 by -1. Did I say -1/3 earlier? It's 5 by -1. Alright. Then after that, 9 by -5/3 plus 5 by 3 gives us this. Then 3 by 2/3 plus 2 by -1. So it's 2 by -1 there. And then we have 3 by -5/3 plus 2 by 3. Alright. So what we have? 3 into 3, 1, 3 into 9, 3, 3, 2, 6, 6, minus 5. And we have 3 into 3, 1, 3 into 9, 3, 3, 5, -15, plus 5, 3 is 15. Then we have 3 into 3, 1, 3 into 3, 1. It's going to be 2, plus -2. 3 cancels 3, so we have -5 plus 2, 3, 6. So when we work this out, we have 6 minus 5 is 1, -15 plus 15 is 0, 2 minus 2 is 0, -5 plus 6 is 1. Alright, so we have the unit matrix, which prove that what we have here is correct. It is indeed the inverse of the matrix. Alright, so remember now, I have to be careful about the mistakes and so on, because I didn't put the negative in front of the 3 at first. Alright, so here, what they say is that PQ is 5, is a vector. Vector PQ is 5, -4. Alright? If P is the point -2, 3, determine the coordinates of Q. Interesting. Alright, what we do, you see? Let's imagine we have a graph here of our y-axis and our x-axis. Just want to visualize what it is we're doing. 0. 1, 2, 3, 4, 5, 6, and so on and so forth on the x-axis. 1, 2, 3, 4, 5, and so on and so forth on the y-axis. -1, -2, -3, -4, -5, and so on the y-axis. -1, -2, -3, -4, -5, and so on the y-axis. They say P is a point, -3, 2. So let's see if we can locate P. We go to -3 and go up here, 2. P would be up here, right? It's above -3 and to the left of 2. So that is P. Alright, just above this and this. So, here now, the vector 5, -4. What that means, this represents x. X goes left and right. If it is negative, it goes to the left. If it is positive, it goes to the right. This is y. Y goes up and down. If it's positive, it goes up. If it's negative, it goes down. What we're going to have to do to get this vector, to get the other point, Q, is to move from P 5 to the right and 4 down. So 5 to the right. We're above -3. 5 to the right will go as 1, 2, 3, 4, 5. It would take us above 2, right? So we are negative. Hold on. It's -2, 3, not -3, 2. My mistake. P is at -2, 3. Alright, so we are at -2, 3. It will be here. That is P. Alright, so it's above -2 and to the left beside 3. Alright, so let's go at it again. 5 to the right, mean 1, 2, 3, 4, 5 would take us above 3. And 4 down, 1, 2, 3, 4, to take us beside negative 1. So Q would be right here. So it's below 3 and beside negative 1. Alright? So this would be Q. So the vector PQ would be this vector then. Alright? So you see that? So let's say the coordinates of Q. So it would be 3, negative 1 would be the coordinates of Q. Alright? So that's part C. We'll continue with the question in the next video.